Welcome back, dear viewer, to the second part of the fire tutorial series. In the first part, we looked at blocking out the overall shape of the fire. In this part, we'll look at dressing it up to look like real fire. And make sure you stick around for the third part to look at adding some smoke and some embers. So, without any further ado, let's jump into this tutorial. So here we are inside of Nuke, once again, right where we left off in the last part. And what we've got here is our particle system that we've created that pretty accurately captures the overall shape of our reference fire clip. And so our goal in this part is to actually dress up our particle simulation a little bit to look more like the fire clip, because right now it's leaving something to be desired. So principally, what we've got to do here is figure out a different sprite for our particles to have, because right now what we've got is just this white circle, and that's not really going to cut it. Fortunately for us, the fire shape can be broken down into chunks that are about the size of the particles that we have here. If we look at our third reference clip here, this one with the slow motion, we can see that the fire tends to break apart into these chunks that are about this big, which are proportionally similar in size to the particles in our particle system. So now we've just got to figure out what makes these shapes look the way that they look. And after a little bit of investigation here, I can tell you that what I notice is this. It seems that we've got some large sort of blobby shapes that have little bites taken out of it. And what that results in is both curved edges and sharp edges. And so I can show you a little demonstration here, an example. If I bring up a RotoPaint node and make a little blob, we'll see if we can make our own little impromptu fire sprite here. There's that, and then I'm going to switch over to the eraser, and I'll take some bites out of it like this. There we go. And we can see we're getting a shape that is pretty similar in just, look to our actual fire here. So now that we know the formula for making this, let's figure out a way to do it procedurally instead of actually drawing each of the frames ourselves. So starting off with that large blob shape that we need, we can actually use our white circle sprite that we have been using as a placeholder up until now. But we're going to need to figure out a way to cut some sort of circular shaped bites out of it, because when I did this RotoPaint example, I am using a circular brush, and that gives us these curved edges and also the sharp edges. But I also want a procedural, organic sort of way to do it. And so we're going to have to turn to our friend, the noise node. Now, of course, I want this to be the same format size as our radial here that we're dealing with, so I'm going to plug that into the reformat node as well. Now we have a noise texture that sits at 200 by 200 in terms of resolution. But you'll notice what we've got here with the noise node is not exactly a blobby looking shape. It is more rough and sort of textured like that. And I'll just let you in on the secret right away. What we're looking for here is the type setting here. We want to switch this from FBM to turbulence. Now we've got these blobby shapes, and what we want to do is use this to eat away at our circle shape here. So an easy way to do that is just to invert this. And if I invert it, you'll notice that it actually gets highly biased towards the white end of the spectrum here. So I'm going to just put a little grade beforehand and adjust the gamma so that it's more even. You can even adjust the white point and black point a little bit. Oh, maybe not the black point. But now we've got it inverted. We can multiply it. We can multiply it in our radial like this. Push it from over to multiply. And you'll notice this doesn't really necessarily look like it's being eaten away. It just sort of combined the two. But if we put a grade node after this, turn on white clamp and bring down the white point and bring up the black point, now we're getting somewhere. I'm going to bring the white point up a little bit more and the black point up to match. And now we're getting a shape that's actually looking pretty similar to our illustration, although I think it's a little bit too detailed. So I'm going to go into the noise texture, and we're going to take down the number of octaves to 5. That reduces the amount of detail. We're also going to reduce the lacunarity down to something like 1.6. And now, if we're looking over at our result here, we're getting some nice chewed up edges. Looking pretty good. I might even venture as far as to bring up the gain a little bit on this. Adjust the gamma. And now, of course, we also want our texture to be animated as well, because in our reference, you'll notice that the shape evolves as time goes on. It just doesn't just stay static. And that's easily done by simply animating the Z parameter in the noise. And, that just changes it in this way. If we use an expression, hit the equals sign on the keyboard, we can do frame divided by 10, and that is going to animate our Z parameter based on the current frame. And I've found divided by 10 to be a pretty good value. It's just a speed control kind of. If we make it a higher number, it's going to be a slower animation, but 10 is decent. So now that we've got this set up, oh yeah, we can see that we're getting some interesting results. I think I'd like to go in and perhaps increase the black point even a little bit more. We want to make this so it's a pretty eaten away shape here. We're getting a nice variety of different shapes and sizes. And now that we've got this, we should take a look at how it actually looks in our particle system. So it's already hooked up to the same particle input that we had our radial hooked up to before. Now if we look in the viewport, this is what we've got. So it certainly looks more interesting than it did before, but it looks a little uniform for my taste. It's pretty easy to see that all of these particles are at relatively the same shape, and that's not really what we'd expect from an organic situation. So I'm going to go into the particle emitter settings and go down to the bottom here, and we'll see an option to start at random. That's going to make it so that each particle starts at a random frame from the input. And now we've got a nicer look. Of course, now I'm seeing that we've got quite a bit of empty space in between each particle here. So I'm going to also open up the particle curve, head over to the size tab, and select everything, bring it all up. Might also increase the maximum size like this. Yes, now we're getting somewhere. This is looking pretty interesting. But it is at this point that I should say the sort of 3D viewport render that we're seeing here is only going to hold us back from now on, because we're going to want to do some 2D processing. So let's just set up a scanline render real quick. We'll go down here, make a scanline render. We'll go with the 3D classic version. Then I'll also bring in a camera, look that up, and move it in the 3D viewport so that we can keep our fire in frame. Tab over to the 2D and see, yeah, that's looking all right. I think I want to bring the Y value up a little bit so we can have a bit more headroom. Oop, it's too much. Okay. So here's what our render is looking like at the moment. And the B box is a little bit distracting there. I'll hit close our items here and then hit Q to remove that. So it's looking all right, but not exactly looking like our real fire clip that we have here. And there are a few things that I'd like to just show you that are going to make this look more realistic. So first things first, I had this alpha curve in here that had this sort of parabolic, inverse parabolic shape. And I found that it tends to look better if we actually shift this towards the beginning of each particle's life, sort of, making it taper off as it gets towards the top. I'll even make another point on the curve, holding down Control and Alt, clicking on the curve to make a new point, then bringing this down. There. Now we've got a bit more dynamic range in the fire. And now here's another very important technique. We can actually create more detail than we have in the sprites because the particles are interacting with each other. You can see that we're seeing particles through each other thanks to our plus blending mode that we've used here. And because of that, if we place down a grade node afterwards and start to increase the black point, we will create new sort of floating islands here that are made up of the intersection points of multiple different particles. And that is just some nice detail that we wouldn't have gotten otherwise. There we go. That is looking more and more interesting. But now, I think it's time that we actually get some fire color in here so we can, you know, make better judgments on what our result looks like. I'll place down another grade node, go into the gain settings here, check the little color wheel, and then we can push it towards yellow and towards magenta, like that. And this more or less matches our reference. So this is looking pretty good, but it's definitely missing something. And I think what's standing out to me is that everything looks very, very sharp, and it's not really flowing together as we would expect from a fire. You can see, you know, in real life, we've got motion blur that happens, and since it's a fluid that's flowing here, we think of gas as a fluid, it's gonna have some sort of flow. And right now, all the particles are moving independently of each other. So how can we sort of fake that interaction? Well, we are going to use the vector blur node. Now this will help us take care of two problems in one. We're going to be able to get that motion blur working, and we're also going to be able to do that sort of flow that we were talking about. But by default, the vector blur node doesn't actually do anything because it needs a map of vectors to blur with. And just so we're clear here, a vector blur is basically the same thing as a directional blur, but the angle and the strength are individually controlled per pixel by a vector map. So to create our basic motion blur for all the particles moving upwards, we just need to do this. We'll make a constant. We'll open up the colors here. Now, green represents the y-axis, so we want to bring that up. We'll blur in the y direction, bring that up to 1, and we'll leave red at 0 because we don't need any blurring in that direction. And then I'll use a copy node, K for copy, to bring the red and green channels of this constant over to the forward U and V channels. We're going to use our forward channel to represent our vector map. And in the UV channels section of our vector blur node, we'll just select forward. And if we turn up the motion amount, you'll see we actually need to turn up the motion amount quite high, so maybe 100 here. We are getting a blur that is just in the vertical direction. And you'll see if we increase the red at all, we're starting to change that angle. Now it's at a 45-degree angle because the red and the green, or the X and the Y, are both at equal proportion. It's also possible just to control the length of the blur by increasing the value of the vector. So here I've just gained it up with a grade. But anyway, now that we've got that understanding established, let's be a little bit more precise about this. First things first, I'm actually going to change the motion blur type to uniform from Gaussian because this more accurately represents how motion blur works, at least in my experimental findings. And then we don't want the motion blur to be constant over the entire length of the fire because the particles aren't moving as fast at the bottom of the flame. You can see that here. You remember these ones are almost stationary, whereas the ones near the top are moving much faster. So I'm just going to bring up a ramp, and I'm going to move the P1 and P0 to the top and bottom of the frame. See what that actually looks like here. It's just a ramp from 0 to 1. And if we use a merge set to multiply, this will mask off our direction vector, so it steadily increases from the bottom to the top of the frame. Now we can see as a result of that, we've got less blur at the bottom and more at the top. Pretty good. But now I would also like to introduce some sort of flowy blur. And so what I'm thinking is I'd like our blur direction to sort of follow the contour of the image here. And this is where I get to show you something really cool. So we're going to enter the matrix node. And when we select this node, it's going to bring up a little dialog box, which lets us specify a width and height. We'll go with the default 3x3. The matrix node runs over every pixel in the image and multiplies the current pixels surrounding neighbors by whatever numbers are in the matrix and then sums it all up. So for example, if we were to just set the middle number here to 1, this is going to be exactly the same output as we have input because the center pixel is the one that's currently being processed. We're multiplying it by 1 and then adding it up with all the neighboring pixels multiplied by 0. So it's the same thing. If we set all the values to 1, and then check this normalize switch here, this is the exact same thing as a box blur. We just get the average of all 9 pixels. But there's something very special that we can do with this. We're going to use something called a Sobel filter, which you may recognize from the edge detect node. It is, in fact, a way to detect edges, but at its heart, it is simply a matrix operation like this. Now, the Sobel operation goes a little something like this. We have 1, 2, 1 on the left side, and -1, -2, -1 on the right side, and we can't have the normalize button checked here. What we get as a result is something like an edge detect, but it only goes on the x-axis, and we're also getting some negative values in here. So it isn't your typical edge detect. The edge detect node does the same thing, but it does it cleaned up and in 2 axes at the same time. But this is perfect for us, because what this is actually telling us, the Sobel operator is a way to approximate the derivative of an image, or basically how much pixel values are changing over space. And the result that we're getting here, you can see as we inch along here, the image is not changing, not changing, not changing, not changing, and then it starts to get a little bit brighter here, and we can see that exactly happening in the output of our Sobel filter. But of course, this is only one direction. If we want to truly understand the flow of an image, we're going to need to have both axes. So I'm going to copy and paste our matrix, and then set this one up to be the sort of turned 90 degrees version. We'll go 1, 2, 1, 0 out the center, and then do -1, -2, -1. And the result of that is a similar operation going in the other axis. And if we combine these together with a little shuffle, we will plug this into the B pipe, plug the other one into the A pipe, and say, okay, our X is going to be red. We'll leave that alone. We'll say from A, take the green, plug it into green, 0 out the blue. And now we have a little vector map, basically. Although an unnormalized vector map, that's important. We've derived the flow, the directional flow of the image just from these Sobel operators. But it's not quite useful to us yet because the amplitude of the vectors are not constant. And so in order to make this useful to us, we need to normalize it. We can do that with an expression node. We're getting a little bit mathy here. It's okay, don't worry. But in order to normalize a vector, we do a hypotenuse operation. That's the Pythagorean theorem. We want to take the hypotenuse of red and green, and we'll divide the red channel by that, and we'll divide the green channel by that. And now you can see it's a lot more even. There are some dark spots because these are negative values, but the hypotenuse of each of these pixels should be 1. We also are going to have some pretty nasty nan values here in places where the hypotenuse is 0, and that's going to cause us a lot of problems later. So what we want to do here is actually, I'm going to make this hypotenuse thing a variable so we can easily refer to it. We'll call it h. We'll say if h is bigger than 0, then it's totally fine. We will divide red by h. Otherwise, just make it 0. And you can see that got rid of the nan value here in our output for that, but we need to do it on both for the red and green. So I'll just copy that same expression and switch out the R for a G. Now we've got 0 everywhere where we had nans before. So just so you can see what this is actually doing, I'm going to plug this directly in instead of our constant over here on the vector blur. And immediately it just sort of nukes the output. We've got a nasty looking thing going on here. But if I place a blur node down so that we're not getting such sporadic changes of direction, we start to get some pretty interesting looking results. It's kind of cool, isn't it? But still, it's not quite what I'm looking for. And one reason we're getting problems here is because we are rapidly switching between negative values and positive values in our map. And when we blur that together, we end up with a lot of, well, the average between a positive and negative is going to be somewhere closer to 0. And that's not accurate to how the direction really changes. So what we're going to do is use a second expression node to just say, if green is less than 0, question mark, then make G negative. Otherwise, leave it as it was before. And if I do that, you can see now we've got positive green across the board, but I need to do the same thing with the red channel as well, because we're flipping the whole vector around. Leave that there. So now, if I look at what our vector blur looks like, aha, there is the shape I was hoping for. Take a look at that. We've got that sort of flowy effect, which is just what I wanted. So that is looking pretty cool, and you can see we can get varying levels of this effect the more or less we adjust this blur size. I'm going to leave this somewhere around 40 for now. But now I want to integrate these two different vector passes together to make one thing. We had this motion blur that was going directly up, and we had our vector blur that gives us this flow. So in order to do that, I'm just going to simply multiply them together. Copy this multiply merge here, and multiply this by this. Multiply our old vector by our new vectors. Now you can see, well, we're getting some kind of a result, but if you remember, this one was just entirely green before. And that means we have 0 in our red channel, and so we're completely knocking out all of the interesting red channel values from our Sobel operation. So what we got to do is actually go in here with a grade node, offset the red channel by 1. So we have just a constant 1 across the board in the red channel. Now we're keeping all that from our Sobel operation, but we're multiplying the Y values by this ramp that we had. And all of that together yields us this. So now we've really got some interest happening in here. I might go in and adjust our blur a little bit more to get the desired result. If we leave it too small, it gets a little bit absurd looking. Maybe up around 50. Now you can see we're really, really getting somewhere with this, okay? Let's just take a moment to preview how this looks. Ah, isn't that cool? That is pretty cool, in my opinion. I think we've got a little bit too much of the Sobel operation vectors coming in here. So I'm just going to go in and simply reduce them down a little bit with a grade. And you'll notice I unchecked black clamp because we are going to have some negative values in there. Although we might just want to go with a change on the x-axis because we want to keep our upwards motion independent. All right, that is looking pretty cool. Now there's a few more things that we can do to spruce this up even further. Let's just go and check back again with our reference clip. Hey, that's not looking bad. It's not looking bad at all. I think if we want to make this more accurate to our reference, we should probably increase the width of our particle directional force because we've got a pretty big sort of foot at the bottom of it still. So I got to go and do the little dance where we set the region to none and then back to sphere. Then maybe increase the scale up to 2.2. 2.4? 2.4 perhaps? And I think it also might be necessary to go in here and, oh, let's look at our result. Might also be necessary to increase the directional force some more, make it taller. Bring it up to 0.03. I could even go into our particle emitter and change our max lifetime to be a little bit longer, so we get a higher fall off here. Ooh, that is too much. Bring that down to 14. And with all that extra real estate, we could probably even clamp down on the black point a little bit further. Get some more crunchy edges like that. Isn't that nice? Furthermore, it's also possible to put a little sharpen on this. I find that can look nice sometimes to really bring out some of that fine detail that can get lost with the vector blur. I'm going to set the size to 10, which really punches it up quite a bit, bringing the mix to 50%, and then also encase it in a little log to lin sandwich, first going lin to log and then back the other way to log to lin. And that just reduces the artifacting that we'd otherwise get from a sharpen effect. And that is looking pretty darn good, I would say. Just taking one more look at our reference here. Not bad, not bad. It might even be wise of us to increase our particle turbulence a little bit more, bring in a little bit more interest in that regard. Could even, I see that just affected the top here. We could even bring down the region controls to affect more towards the base. We'll see how that looks. And I think that is looking quite good. So I'm going to call it here for this part, and make sure to come back in part 3, where we will together look at the creation of some smoke and embers to go along with this. Once again, I have been Julian Cruiser here with the Foundry. You can find me on nodesaren'tscary.com or here on YouTube at nodesaren'tscary. I hope you enjoyed the video, and I'll see you in the next one.